Alright. Sorry, you got a little shot of me. It's terrible. I hope it doesn't give you nightmares. Okay. So now we're on to the second part of 2.1. And this is kind of the important part. So we're going to talk about something first called evaluating. Okay. So what I have up here is I have an expression. And I want to evaluate that expression. And I do that by using what we call order of operations. Now you might remember from school an expanded order of operations, and we will learn that in this class. But for right now, we're going to start with multiplication and division, left to right, and then addition and subtraction, left to right. Now when we're dealing with this, it doesn't matter which one comes first. It could be multiplication, could be division. Whichever comes first, we do first. But we always start from the top, and we work our way down. Okay? So when we're evaluating, start with the top, work our way down. So with this particular problem, we would go 3 times 2, which is 6. Okay? And we still got the plus 1 here. 6 plus 1 is 7. Alright, and that's how we would do. Now, what we're going to be dealing with here are equations. And we're solving. And solving works a little bit different. With solving, you start from the bottom, and you work your way up. Okay? And the way I like to think of this is kind of like a murder mystery, although murder is not a good thing. I'm not condoning murder. But with murder, somebody's going to commit a crime. First, they get motivated. Okay? Then they use a weapon to hurt somebody. And then you've got a dead body. Okay? So, motivated, weapon, dead body. As a crime scene investigator, your job is to solve the crime. Well, you start with the body, then you figure out what the weapon is, then you figure out the motivation. So when you're solving, you're working backwards from the way something would work. Same is true with mathematics. We do things opposite. Okay? So we are always going to get rid of addition and subtraction first, and then multiplication and division second. Okay. Now, since we're doing one-step problems, it's not that big of a deal yet, but this will be important later on and something we're going to spend a lot of time on. So here I have an equation. And if we look at this equation, we have b plus 2 equals 7. And you could probably figure out in your head, well, that's a 5. 5 plus 2, that equals 7. And that's fantastic, okay? And the reason we start with these really simple problems is so that we can see the answer. Because we want to be able to see the answer easily so we know whether we're doing something correctly or not. But really, the most important part of this is the step. And you'll notice a lot of the questions on the quiz deal more with the steps, than they do with the actual answers. Some of them deal with answers, but the steps are the important thing. Because then when we're dealing with problems that are incredibly complex and we can't do in our head, we can still figure them out. So what we want to do is we always want to do the opposite function. The idea is to solve the mystery here. What is the mystery of b? So to figure out what b is, b has to stand alone. It has to be all by its lonesome. Okay, it has to be by itself. So we need to get it by itself. The problem is right now we're adding 2 to it. So we need to get rid of that 2. So we look at what's the opposite of adding 2. Well, it would be subtracting 2. Now we talked, and this would get b by itself. The problem is we just changed the equation. Okay, it's not in balance. It's not equal. So we need to remember the whole principle of equality, right? If I've got the teeter-totter, okay, the teeter-totter just went out of balance. We need to get it back in balance. Whatever we do to one side of the teeter-totter, we have to do to the other. So if I'm going to subtract 2 from this side of the equation, I can maintain the balance here if I subtract 2 from that side of the equation. So now I have b by itself. 7 minus 2 is a 5. And there's what you probably already did in your head. You knew that b was a 5. But we did it algebraically. This is the important thing to learn. I don't care about b being 5. What I care about is you subtracted 2 from both sides. Okay? Let's deal with this one over here. Let's solve for x. We want to know the mystery of x. X is all by we want to get x all by itself. Problem is we're subtracting 4. So what's the opposite of subtracting 4? Adding 4. We do it to one side of the equation. Got to do it to the other. So now we have x equals 10. Okay? Same thing's true here. We've got 2 times r equals 6. And by the way, when you take a number and you butt it up next to a variable, you're implying you're multiplying. So I need to get r all by itself. Okay? The problem is I'm multiplying by this 2. So I need to get rid of that. Well, what's the opposite of multiplying? Would be dividing. Because the 2 over 2, well, what's 2 divided by 2? It's 1, right? 1 times r is simply r. So the 2's are essentially canceling out. They're turning into a 1, leaving us with r all by itself. Now, since we did this to one side of the equation, to maintain the balance, we have to do it to the other. 6 divided by 2, 3. Okay. And finally, we have t divided by 2. So just like here, what's the opposite of dividing? It's going to be multiplying. So I'm going to multiply both sides by 2. Okay, I'm going to have 2 over 2 again, which is going to leave me with t. 5 times 2 is 10. Now, the great part about all of these problems is that we can always check our answers to make sure that they work. I could plug this number back in here. So 5, plug it in. What's 5 plus 2? 7. Plug the 10 in here. What's 10 minus 4? 6. It works. Oops, sorry, you didn't see that. And down here, plug this 3 back in for r. What's 2 times 3? 6. And down here I could check it. Plug 10 in for t. What's 10 divided by 2? It's 5.